Welcome you all to this new series of videos lecture from Enam's Explain channel. This series is based on engineering statics problem from Hibbeler 14 edition book. In this and onward series of video lecture, we will be solving the fundamental problems of chapter 2 named force vector from page number 28. So this is the fundamental problem number 1 in which we will be determining the magnitude of the resultant force acting on the screw eye and its direction measured from x-axis clockwise. So in this problem, we have two forces, 6 kilonewton, 2 kilonewton. 2 kilonewton is acting downward at 45 degrees clockwise from x-axis, and this 6 kilonewton is acting downward from this x-dash axis 60 degree anti-clockwise direction. So we'll be determining the resultant force and the value of its direction or theta of the resultant force from this x-axis. So first of all, I will be naming these two forces as F1 and F2. I named this force F2 kilonewton as F1 and this 45 degree as theta 1, and for the other force F2 I named it as F2 and this angle is theta 2. So we'll be determining the resultant force. So for this we will first know that the axis, that where is x-axis and where is y-axis. For this I am drawing two horizontal and vertical lines. So here it is vertical line is also called as y-axis, so I just drawing the y-axis line. So now for a vertical horizontal axis, I will be moving this ruler at 0 degree, which is at 90 degrees from the vertical axis. So now I will be drawing the horizontal axis, which is also called x-axis. So after knowing these horizontal and vertical axis, we also know the values. This is x1, this is y, this is x-axis, this is y, positive values because it is like origin, and this is x dash, y x dash, because all the values from the left from this point will be in negative, and this is y dash, as we know that y dash it also yields negative values if we move downward from this point to down, so we can get all the values in negative. So now we will be resolving each force into x component and y component. So we have F1. I will be resolving this in the x component and y component. So its x component, look here. So the x component will be equal to, from simple geometry, the x component will be F1 cos theta 1. So it's by using the Pythagorean theorem or by the simple geometry formula like cos theta, sin theta, tan theta formulas. So by trigonometric ratios, we know that y it is cos theta, y is sin theta. So for y it is F1 sin theta. And similarly for this F2 forces, the x component will be here, acting here. So the x component will be F2 cos theta 2, and the y component will be here. So it will be F2 sin theta 2. Remember, this is from simple trigonometric ratios. Now first I will resolving the force 2 kilonewton into x component and y component. So for this I will be using the formula as I mentioned here, that for F1x it will be F1 cos theta 1. So putting the value of F1 as 2 kilonewton and cos theta theta 1 is 45 degree. So we can get the value of F1x, it will be 1.41 kilonewton. Now also mention the direction, that it is acting here on this side, on the right side from the origin, so it will be positive, remember this. And similarly for F1y, mean y component of this F1 force, it will be F1 sin theta 1. So F1y equal to F1 value is 2 and sine 45 degrees. So the value of F1 force will be 1.41 kilonewton, and its direction will be like, look at the arrow of this F1 force, it acts downward. So the downward value for the y-axis will be in negative, so it will be minus 1.41 kilonewton. Now I will be resolving the this F2 force. So I will be resolving the F2 force into x component and y component. So I will be resolving this. So for this I have the same formula as I discussed earlier for F2x. For F2x we have this nice formula, F2 cos theta, as this formula we get from the trigonometric ratios, putting the value of F2 and theta So the value of F2 is, the value of the F2 value is 6 and cos 60 degree. So after putting the values of 6 and cos 60 in calculator, we can get the value of F2x is 3 kilonewton. 3 kilonewton. Now F2x, look to this force. The x component is acting on the left side, so it will be in negative, because as we know that from this point the left value for x-axis will be in negative, and like for y-axis downward will be negative. So it is the same as I discussed earlier. For F2y, we have the formula from the trigonometric ratio, that F2 times of sine theta 2. So putting the value of F2 6 and sine theta is 60 degree. So we can get the value for the F2 is 5.196 kilonewton. This is the F2y value. So it's moving, it's acting downward, so it will be negative. Now I will be just doing adding this summation of f of x, the x values and y values. So for this, we just simply add the value of the summation of f of x. It means that add f1x plus f2x. It simply means like that, summation of fx. We need this for resultant force magnitude and direction determination. So summation of f of x equal to the value of f1x is 1.41, and plus the value of f2x. F2x is minus 3. So adding these values, we can get the value of summation of f of x. Summation of f of x will equal to minus 1.59 kilonewton. Now I will be adding I will need the value of summation of f of y. So for this, summation of f1y plus f2y. Adding the value of f1y is minus 1.41, plus the value of f2y is minus 5.196 kilonewton. Adding these values, we can get the value of summation of f of y, which is equal to minus 6.606 kilonewton. So we have two values. Remember these two values. And now for the resultant force, we have a nice formula for the, as we know from the mechanics, that the formula for the magnitude of the resultant force is this summation of f of x square less summation of f of y square. We know this formula for the resultant magnitude of the resultant force. We have the value of f of y and f of x. We just put the values in this formula. So putting the value of summation of f of x is minus 1.59 and summation of f of y is minus 6.606, as we have determined here. So after putting the values and applying the square root, we can get the value of the magnitude of the resultant force as 6.79 kilonewton. So we found the value of the magnitude of the resultant force. We solved one part of the requirement of the question. Now we'll be determining the direction of this resultant force, where it looks like. So we have the magnitude of the resultant force. Now where it is looking in this question in XY plane. So here we have the Fx value and Fy value for this resultant force. So the Fx value is 1.59. It's like from the negative side, from this origin of the left side. So we have 1.5 is here. And we are assuming that summation of f of y value is minus 6.606. So it will be somewhere here, and we will be matching these 2 points. So matching these 2 points, we have drawing this line. So this will be this is a straight line. This is the resultant force. So I will be magnifying here, like it is like x-axis, y-axis, and it is minus 1.59, and here it is 1.59, and so we have the summation of f of x and summation of f of y. This value is minus 1.59, so it will be somewhere here, and summation of f of y value is minus 6.606, so it will be somewhere here. So I will be trying, just assuming that my force is located here. So from the origin, the resultant force is located here. So I'm assuming this the position. So the main thing is that I will be determining their the like this angle. I will be determining this angle from the this x dash. I will be determining the value of the resultant force, and then I will do further calculation the angle measured from the x-axis. So for this we know that theta equal to tan inverse summation of f of y divided by summation of f of x. So putting the value tan inverse summation of f of y is minus 6.606 divided by minus 1.59. So we'll get the value of the theta is 76.5 degree. 76.5 degree is the angle. So we have not reached to the question requirement. At question it says that measured from x-axis. So I will be magnifying that we have determined this angle. Like this is x-axis, and we have this resultant force F. We determined this angle as 76.5 degree. So I'm naming it as alpha. So we need this from this axis. We determined from this x dash axis to the resultant force, but actually in question we need this x value. This is clockwise direction from x-axis. Here you can see that clockwise direction from the x-axis. So we have this straight line, and the straight line is 180 degree, and we have this angle. So we need this angle. So subtract this angle alpha. This angle from 180 we can get this angle. So I'm repeating this, that what we'll be doing here, we need the value of the theta. So we have this resultant force, we have this angle, I named it as theta. So we have this theta 76, we need this angle, I'm naming it as alpha. So alpha will be alpha. So this alpha will be equal to since alpha plus theta yields 180 degrees, means if we add alpha plus this theta we can get 180 degree. So we need alpha, means this angle from this x-axis to this resultant force. So it will be 180 minus theta. So alpha will be 180 degree minus theta is 76.5 degree. So subtract this, we can get the value of alpha, which is 103.5 degree. So we have know these the answer of this question is the resultant magnitude of the resultant force is 6.79 kilonewton, and the direction measured clockwise from the x-axis to the resultant force is 103.5 degree. So if you have any further question about it, just comment below or text me. I will be responding your questions. So I hope you can understand the basic concept of solving this type of question.